Hello, everyone. Good evening and welcome. Hopefully we've got an interesting event tonight with some good discussions. I'm very excited to hear what these folks have to say. So my name is Jeff Johnson. I work at Accenture. For those of you who have not heard of it, it's a massive technology consulting firm. My job is a transition lead or transition manager, so I'm responsible for making sure my clients, any buzzword you might associate with this program, analytics, automation, artificial intelligence solutions, any solution like that, my team's responsible for managing it, tracking it, and implementing it. I also teach BizStats 207 as well. So that's what I do. I'll let the panelists introduce themselves.
Hi, my name is Soleil Fortin. I'm a supply planning manager at Happy Family Organics. I'm a graduate of MBED, and I did my undergraduate in economics.
Hi, my name's Angel Diaz. I did my bachelor's here at Boise State as well, and in business analytics, got a minor in computer science, and now I'm adjunct teaching a spreadsheets course. So I teach awesome Gen Zers how to spreadsheet, and I also I'm a data engineer full-time, and I work remotely. And just a quick explanation of engineer versus scientist. Data engineers like back end, and data science is more front end. So hopefully I can catch the interest in the back end, or sell the back end a little bit. So yes.
Okay.
Oh, you got yours.
I got my own mic. So see if it works. Hello, my name is Henry Holliday. I work for Mars Wrigley. So if you guys have ever eaten a Snickers or M&Ms, that's what I do. I sell candy essentially. I'm the account manager here, working with Albertsons. I grew up in Idaho. I left though for school, so but it drew me back, and I was a finance and marketing major. Excited to be here tonight.
Hello everyone, I'm Randall Shane. I'm PhD computer science, machine learning at Stanford. I was a startup guy in New York for many, many years. I was always the chief technology officer, chief data scientist, etc. I will tell you, in startups, I had 2 of them go well. One made its way along, and one catastrophically imploded at the 91st day, which is always exciting. So I've had a varied amount of experience. I teach ITM 415, which is advanced database design, and I run a development company here called Code Intelligence.
Awesome. So as you can see, we've kind of got 2 little groups up here. So we've got kind of a business background, and we've got kind of a technical background. So the goal for tonight is to kind of walk through some questions and have each kind of group give kind of a business answer and a technical answer. We've got some pre-prepared questions. We're going to move through some of those. We're going to talk about kind of skills in the industry that are important. Then we'll move on to kind of data science or analytics kind of best practices. And then we'll see where we're at on time and either open it up to questions for the audience or hit some kind of just general career questions. So that's kind of the structure of the evening. So let's dive straight in. So first question we're going to jump into, pretty obvious right off the bat, is why is data analytics important? And how are statistics used in your company and your organization? So that's a pretty broad question right there, but we'll just start over here.
Great. So my role specifically, we do forecasting, right? So the whole idea is that you have to use statistical models to come up with the right forecast. So it's just very integral to my job. If you're a supply chain major and you're looking into doing something in the planning world, that's just it's a given that you'll be using statistics there. I think that the interesting way we've been using statistics recently, though, too, is to just develop KPIs with so key performance indicators with our co-manufacturers, and it's given us. I think that what's been fun about using statistics in that way is it feels like a fair grading system, if that makes sense. Like you're not just subjectively saying this is good or bad. You're able to put numbers to it, and I think that's been the most fun for me recently.
So data analytics important. Yeah, it's pretty important. I work at ClickFunnels, which is a marketing software firm, and so one of our biggest challenges that we take on is churn. So churn, in other words, is, I'm going to mess it up. So it's basically we want to reduce the amount of people who are dropping the software, dropping the subscription to our products. And so we use statistics, or our data scientists use statistics to predict likelihood of churn based on certain actions. And so those actions are taken in as data, and then you get to the statistics with the data scientists predicting, okay, maybe we can catch these people before they churn or leave, and we can actually have them be a recurring customer or continue to be a recurring customer, because it's much easier to keep a customer than to spend money to get a new one. So that's how statistics, that's the main way I've seen it at my company.
Still on? So yeah, for me, is it on? Can you guys hear me? Okay. For me, like, data obviously is extremely important in our industry. So I'm in sales essentially, but today I was just running an analysis trying to understand and leverage data from historical data to future consumption data potentially to figure out what type of program I should be offering to my customer to deliver the best return on investment. So we're taking all these numbers, trying to really understand what do they mean, what do we think they're going to do, and then obviously from a financial perspective too, I have to understand what is my financial risk for myself, the organization, to really make sure we're putting the best program together mutually for myself, for our client, to get more candy sales essentially. From a statistical standpoint though too, we like to really leverage statistics to run some simple things as like test and control. So from being a large organization, if we make a drastic change, that could cost us hundreds of millions of dollars. So we run statistical models to understand if we make a new change and go a different direction, or change an even item just on the shelf, honestly, what is that impact going to do? And by doing that, then we can run confidence levels to figure out if we make this change, is this something we should do for the long term, and what kind of return is it going to bring? Or is this a huge risk that it could potentially implode the company and lose a significant amount of money? So,
The combination of statistics, analytics, business intelligence, whatever we want to call it and whatever we're going to call it next, provides insight. The reality of any product operating at scale is that you have more users and more data that flows through any product that any one person can know. You cannot look at any component of data or distribution of it and say, I know what happened looking at this. If you have 100 million entries, the human mind cannot hold that much data. So you can't really look at that and infer trends and infer other components of the information that's there. We need to digest information at a higher level, and that's why we use things like summary statistics, we use analytics, we use trends, we use visualization. The overall point of all of these, we live in a world that has a lot of noise with a little bit of signal within that noise. And so for us to digest that, we need a little bit of higher level math to be able to help that digestion.
So what skill sets are really helpful in understanding that higher level math? Like what programming languages, MySQL, Python, C++, like what type of skill sets and tool sets do you use to apply that higher level math? And maybe we'll start down with Randall again.
I think there are some pretty simple basics. I would say off the bat, no SQL. SQL, structured query language, you should know it, and you should know it well enough to be able to operate in the environment. That's first and foremost. Not everything you will look at will fit in a spreadsheet. And spreadsheets are great, they're super flexible. However, they are limited in size. So first and foremost, no SQL. Second, I would tell any person who says, I want to be anywhere in the data science, architecture, machine learning, artificial intelligence, learn Python. Learn Python, number one. The libraries that support it, everything from scikit-learn to TensorFlow to being able to use the Watson stuff offline, all of that is very significant. And Python is a very simple language to learn. It has a lot of what they call Python, it's the Pythonic method. It's an enforced method for the construction of any module or library that's there. So if you know how to use one library, while the syntax will differ, you'll know how to use another library. It's a very simple language to start with. Third, and it's less of a programming language, statistics. Take a stats class. Take a stats class here at BSU. Take a stats class online, but take a stats class. You will look at numbers differently after that. And I think those three things in combination give you a leg up.
So I would agree with pretty much everything Randall just said. Python and SQL, Python and SQL. Those are definitely the way to go. Whether you go the analysis route, which is kind of data science and more math and statistics, still you want to use Python. I know R is awesome. I'm a big fan of R, but I recommend Python because of its versatility, especially the culture here in the Treasure Valley. If you pick up R, and you go to a software developer, a senior software engineer for help, they might say something like, oh, R is a toy for statisticians. While I don't agree with that attitude at all, you still want to don't put that barrier in front of yourself and learn Python. And then if you go to that same kind of jerk senior software engineer, and you say, can you help me with this Python thing? They're going to be like, yes, I would love to do that. And Python is great. And they might even have some snobbish opinions about Python, but maybe they're too far gone if that's the case. But SQL and Python, and the last addendum I would add is if you are hopefully interested in my route, which is more the data engineering route, the back end of data, then I highly recommend you learn shell scripting, Bash and Linux, or Unix, which is Mac. Mac uses Unix, so learn Bash. Or if you're on a Windows machine and can't get off it, you're a prisoner to Windows, use PowerShell. And if you learn both of those things, scripting, just moving around files, like copy and paste in Bash, you're setting yourself up for employability. Yeah.
All right. Well, I'll let these technical guys answer that question first. But, I said, so I don't necessarily use SQL all the time, or sometimes I use some stats. But it still is extremely important to understand from a business perspective. So we do have people that are running those numbers, running the analysis, putting things together for us to help us and make those decisions internally. So again, while I may not be on the back end user side of it, using some of this information or doing some of the information, we definitely are leveraging it to figure out how to make the most optimal business decisions, how to leverage that to, I said, drive return on investment for our organization, and continue to challenge how do we continue to get better with the data and insights that we have.
And just clear, do you code at all?
I do not actually code.
Do you code or?
No, well, VBA, which is...
Yeah, we do like VBA,
Yeah.
Access, VBA, stuff like that, so
Yeah.
macros. But.
Just for kind of general awareness for us, how many folks are in the business school in this room? Are there any developers or like computer science majors? Any folks? Yeah, got a couple. Okay. So interesting.
Doesn't matter. Learn Python.
I agree. I wish I would have learned it. So no, it's all time. So.
And I'll comment really quickly on that, just from my perspective, because I'm not coding regularly in my job. But I think that the structure, how you structure databases, also helps you process and organize information for your company in a way that is really useful. And all these data points we're talking about capturing, if you're not capturing it in a usable way, then those numbers aren't as useful in general. So I just want to put that, I always have this general appreciation for people who are coding. I think that your approach and that mindset is really important. And I've seen bad databases, and it's not fun.
So.
Yeah.
Might shift this question more to kind of the business side. What skill sets are really helpful in processing kind of the outputs of those databases? What are skill sets that are really, really helpful more on the business side of absorbing that analysis?
Yeah, sure. So I think being curious about the numbers is really important. I think with stats, there's a lot of times where it's easy to you have all the data, it's giving you an answer, but then what does that mean for you, and how are you going to take that information? And kind of get the team behind a decision point is important. So from the business side, I would just say there's really not a lot of decisions that I make where I don't run a model or do some sort of spreadsheeting to have as a backup to get there, to try to get the right answer or the best answer that you can't have at that time.
Yeah, so for me too, it's about just being curious. So there's a lot of data, right? There's a lot of information out there. So how do you look at it? How are you curious about it? And trying to find that needle in the haystack sometimes, which is difficult. So sometimes finding a clear objective and finding a clear objective to figure out what is that, we call it actionable insight. So there's a bunch of data and sometimes garbage in, garbage out. So what are we trying to accomplish? So how do you leverage that? So really being curious, digging around into the data, leveraging the different resources that are available out there. And again, same with you, I do all of my decisions are based off some type of data or insights. I may not have every single answer from the data, but I leverage that to make the most responsible decision to then move forward in the organization and the business.
I'm curious about, the panel's title tonight is, data decisions in business. Do you let the data drive decisions in your organizations, or does it just get a vote? And maybe to clarify that, or do you have automated processes where you run numbers and it spits out and things automatically happen? Or when you're forecasting or when you're looking at sales numbers, building plans, or is there any time you kind of go against the numbers or kind of go against the data?
Yeah. So I think that our approach is really kind of bottom up is what you're using the data for, but you do have to have these top-down kind of goals. So if the numbers aren't telling us what we want them to tell us, we will make decisions that get us closer to where we need to be.
That right, there's a great statement. The data's not telling us what we want it to tell us.
Right.
I'm in sales.
Unfortunately, that's it, and it's usually some sort of sales goal or something. So the organization's going to have decisions that are made outside of data, but how we're going to get there ends up you still need a SKU mix, so it's going to have to come back down into the data to be executable.
Yeah, sometimes just the way you're looking at the data. So obviously we want to run the facts and information, but to your point, there's a lot of other facts out there that probably could maybe help articulate the story that you're trying to get to. Obviously, we want to do what's best for the organization, the business, and the partnerships that we have. But yes, you can kind of leverage those different skill sets to figure out the story that you potentially want to create if you need to. So,
what's your guys' response to that?
Don't beat us up.
I build products for clients, and the data is very much you could lead a horse to water. And so I have clients that are very, very good, and they listen to what comes out. And you made a good point earlier, Soleil, about picking KPIs. You can run data 50,000 ways. Pick the things that track what you want to track. If you need to track customer engagement, track customer engagement. If you need to track sales, track unit sales. If you need to track unit acquisition or customer acquisition, track acquisition. But pick the KPI goals that make sense. Make sure that the data that you have properly reflects those, and then report the information as accurately as possible. From there, what happens is sometimes a wrestling match. And so in some organizations, it's very well absorbed, and you'll see organizations make make decisions based directly on that information. In other organizations, it's not so well absorbed. Your role is to back up your position with information, always. Not, I think, I feel, my opinion. This says this. Clearly we are doing it well, not doing it well. And back it up. And if you have the information to back it up, and there are extenuating circumstances, for sure that's part of it. But I think you have to kind of keep in mind, and I think it depends on really what side you're on. From a programmer's perspective, my job is to try to give the clearest information that I can provide without bias.
Yeah, I think I would add that I would echo a lot of that sentiment. That ultimately, we're dealing with humans here. and humans have opinions. And so they, I don't want to name, I guess, companies that I've worked at, but every company has data integrity issues. Every company has data quality issues. And in those issues or discrepancies, you can find people will disagree on which number to go with or what database to go with. And so there's always opinions that we have to run into as either engineers or scientists or someone presenting numbers to. You always have an end client, whether it be a client, a manager, or a coworker, and there's always that gray area that you can't really learn in school, but you definitely will see it as you work with people outside of school.
Yeah, that's a crazy simple question, but can be extremely challenging in organizations. Well, finance said the number was this, but sales said the number is this, because their database said one thing and their database said the other. So even getting to agree, like we're not even doing analysis. We're just talking about like what's the number. As I see some smiles over here, like that's a very common problem. I'm really curious to know maybe about a time when an analytics problem or an analytics project or model went really, really well. And maybe we'll start on this side of the table.
Sure. So, this might be boring, safety stock. So we've been analyzing our safety stock model for, it's years. It's a continuous improvement thing. You continue to want to get better at, your stock modeling. And so I think that that's been one where you can take just the base of a safety stock model. You can look it up online. And we've continued to tweak and add, okay, we're also going to cover for deviation on delivery performance, and we're going to, so my safety stock formula is very long, and it's so fun, and I love showing it to people. But that's one of the projects, too, where when I do end up showing some people in our company, they're like, well, that sounds like you're being too safe, like you're covering for too much, and I have to explain, no, it's all under the same square root. So, it's like this, trying to explain a little bit more of the statistical, a framework of it. And anyways, math doesn't always compute for everybody. So, I think that that's a really important part of us, being able to understand where the numbers are coming from, so that you can have conversations with people. Because at the end of the day, we are trying to drive business decisions together. And so the communication for what we're getting out of our statistical models is very, really important.
Can you repeat the question?
When was the time that a model you built went really well, or drove a decision that had a really positive impact?
I'm going to, so I haven't done data science work, which is the statistical modeling, so I'm going to make the executive decision to change the question around a little bit. What's the...
You're not supposed to tell us.
What's the time you solved a database problem that led to great business wins? Great question, whoever asked that. So there was a business rule in a company I worked for in the past, in which the balance that we would show, the total balance, and then the sum of their transactions would always equal to each other. And so we assumed this business rule was always true in the database. Except I kept getting tickets from the customer saying, these two don't match. Why don't they match? And so I had to find the root cause, do a bunch of work for every single client ticket. And also every single one of these clients is a small loss of customer perception of our product, right? Because they're thinking this product isn't working. And so what I did was did a very simple query. And it was just a cross database join, just a simple join, which you cover in ITM 315. And a single where condition where the sum of the transactions does not equal the balance that we're showing. And so that showed me a couple dozen of accounts that were breaking this business rule. And so I think that goes to show the importance of critical thinking. To brag about myself a little bit, question the business rules, question when you're seeing something that's not quite right, question it. Curiosity, as you mentioned earlier, is such an important factor in your success, no matter what, if you're doing databases or models. Yes.
Before we jump over to the next group, I'm going to flip the question on you. When did you see a model or numbers that led to a bad decision?
Let's see. So I used to work for Campbell's Soup. So if you guys ever had Campbell's Soup, pretty good. Has a lot of salt in it though. So there was a business decision when I was there that was made due to the high amounts of sodium, and due to what they were hearing from customers, they wanted to be more healthy, right? So our decision was, hey, sales are slowing down. Why are sales slowing down? Well, people want to be more healthy because we have too much sodium in our soup. So the best way to solve it is to take out the sodium, right? Because that's what the data was telling us, or what we thought the data was telling us. So we took out a bunch of sodium. When you take out a bunch of sodium, what happens? Doesn't taste as good. So sales plummeted even more at an even faster rate. So that was a rough year for us. And then we realized, so why are sales plummeting even more? People said they wanted less sodium, right? That's the data was telling us. But just because sometimes what somebody's telling you doesn't mean that's what realistically is going to happen, right? So if you go to McDonald's and they don't put salt on your fries, you're probably going to be like, it tastes different. So essentially what we decided to do, we decided to put the salt back in and the sodium back in the soup, but then also create, for those consumers that did want a lower sodium diet, a healthy choice soup, so we could still balance between those consumers that said they wanted healthier, who were actually going to buy healthier, versus those consumers who said, I want healthier, but really I still want my taste, so give me the sodium back. So we learned and lost a lot of money. So.
Okay, I have a combination fail. So I did some work with an internet retailer, and they stocked about 33,000 SKUs, and they had their own distribution centers, their own inventory, everything that goes with it. And they had a data warehouse, and the warehouse had functional flaws in it. So they were making decisions on information that was duplicated at minimum within the warehouse itself. So once that was fixed, and we're able to actually take a step back and look at what exactly is selling, of the 33,000 SKUs, 99% of their inventory was the top 100 products, and 99% of sales was the top 100 products, and 95% of sales was the top 50 products. And so faced with, okay, you have way too much stuff that no one buys, or people buy once a year, that needs to be trimmed down to save inventory space and everything that goes with it. And then additionally, you have a huge problem in the data warehouse and the way that the information is architected. And interestingly, they chose to remain with the existing data warehouse staff and errors that they had, largely because if they fixed it, it showed a reduction in traffic that was unappealing to investors. So there are many times where when you fix these things from a technical perspective, and I always look at it from that perspective of how can we make this the most accurate thing in the world, there's a lot of other considerations outside of it. And if they've done business that way for some time, you fight an uphill battle getting people to even listen. So they failed. Catastrophically, they failed.
And I saw you shaking your head. Do you want to kind of add on that, or you got a similar story of
Yeah,
what,
no.
what are things that you've seen go poorly, or mistakes, excuse me, like common errors and mistakes when building models and applying data?
Yeah, I've seen in web traffic data specifically, a lot of web traffic is bots, and a lot of marketers aren't willing to accept that because they're competing against people who do report the bots as real people. And if they were to, cut down their traffic in half or whatever it might be, then that's going to put them at a disadvantage. And so here, again, we come across humans are going to have their opinions about things, and that comes before the numbers sometimes.
What about maybe on kind of the business side, just kind of that broader question of like, what are common mistakes? I'm actually really curious, Slay, about forecasting. Like, people are terrible at predicting the future. So like, how do you kind of mitigate that with forecasting, saying this is what we're going to do, this is what our safety stock for this SKU is going to be a year from now? Like, how do you make sure you're not making mistakes when you forecast and it is inherently wrong to begin with?
That's a tough question. If I have an answer, it's a lot of grit, I think, for us, because we actually forecast in Excel. And we use shipment history as, for some data. You don't have, there's different data sources, I guess, for every customer. Some customer you can purchase the point of sale data, and so you know exactly what's being sold by the unit. Other grocery store chains, that same information is not available. Some customers, we know what inventory they have in their warehouse, which helps us forecast what kind of weeks of supply they like to carry. So it's really just a whole slew of putting together as much of this piece of much of these pieces as you can to get a good forecast. 85% is probably best in class forecast accuracy. If you're looking at M-1, that's pretty good. We've been there. It's getting bad recently. Dropped a couple percentage points, but we're struggling right now with the finance versus forecasting calendar months, down to the day. We're trying to get a forecast to understand what are we going to land this month, what are we going to land next month. And we forecast in weeks, so that already introduces a challenge. So I don't know if I answered it how we do it. We just try really hard. And use statistics to say, does that make sense, right? So there's a lot of charts that we have too that say, visually, does this make sense? Because we can't pair through it all, and that's the best way we've found to catch things that are wrong.
Go ahead, Ryan. That's a loaded question, and that's unfair. But let's see if Randall, let's see what he's got.
It's interesting because I'm kind of living this at the moment. Every forecast is underlaid by three components of a time series decomposition. A forecast is in itself the trend line. Is it going up? Is it going down? Take basic sales. Are you selling more? Are you selling less? The second component of that decomposition is seasonality. Do you sell it more in the spring, more in the summer, more in the fall? Certain things make lots of sense. You don't sell lots of skis in the summertime, right? But the third component of that is randomness. And that randomness is caused by things like Cyber Monday, Black Friday. Did you have a promotional sale? Did you have a blowout sale? And so when you start to decompose forecasts into different components, you start to get some idea of how you can bump your accuracy on those pieces. And so sometimes the world of, I'm living this at the moment, the world of forecasting is very, very interesting from that standpoint. But the big thing that I think oftentimes people look at the number and they say, what was it before? What is it now? 2 points make a trend. 2 points does not make a trend. Regress a line through many points. But the next piece after that is you have to add a third axis, and the third axis is time. And time gives you those components of seasonality. Once that's added in, I think you have a far better basis to actually project forward than to just say, 5% more, maybe.
I think that's good. I
mean, I just like the randomness is a huge one too. So obviously we're using the data that we know and the trends that we have, but if Kim Kardashian or Dr. Oz says something, that could be a factor that we didn't predict and plan for. So there's social media influences. There's a hurricane. So we see, being in the food industry, if there's a hurricane, people run to the store and buy a bunch of food, right? So then we're out of stock. So as we look toward next year, then it's understanding too, what were those outside, maybe random factors that occurred to ensure that we predict what will happen, going forward to have the most accurate forecast.
Yeah, I have two short things to share on forecasting. There is an awesome talk. I forgot the guy's name. He works at Facebook, and he built this, I think it was a Python library called Prophet, and they do tons of time series forecasting. It's really cool how the model is actually really quite simple, and it's awesome. And I don't even do statistics really. The second thing I wanted to share was to add on the randomness idea. is that sometimes a number goes up and sometimes a number goes down. And sometimes a business owner might want to know a reason. They need a reason from you. And sure, you can torture the data long enough to give you an answer, or you can come back and give an unsatisfactory, it just did. And that happens sometimes. And I think we need to acknowledge that a little bit more in the data world. Yeah.
I think and so often in the data world, you're able to measure things out to 3, 4, 5, 6 decimal places, and it kind of creates this illusion of precision and accuracy when Kim Kardashian tweeted about something, right? So it's such an interesting dynamic. Maybe we'll do one last question kind of for the panel, and then we'll open it up to the audience. But maybe just talk about what's the best part of your job, or what do you enjoy most of working with data, and what do you really enjoy kind of rolling up your sleeves and diving into for a day?
What I enjoy most is the fact that I get to work with data so much, because I feel like I know more than everybody else. So it's like, because that's my job, to spend the time in it, I get to have the answer, which is super fun, right? To be able to guide decisions and help make the best choice. Even when we go against what the data says, I still feel like that's a fun way for me to contribute at work, and it's definitely my favorite part.
My favorite, I'm going to give a non-PC answer. And my favorite part about my career specifically is the autonomy and money it brings. I know a lot of students are into data analytics because, well, yeah, it pays money, right? And I think it's okay to acknowledge that. And as specifically working with data, I just love building data pipelines and putting them together and seeing an analyst have access to data in an easy to use format that they didn't have before. And I view that my role in a service role in like a service minded. And so I serve the analyst so that they can serve the business users. So that's what I enjoy most about my career. So non-PC answer and then PC answer.
So my job, I sell candy, so it's pretty fun. So that's what I do love about my job. I can't go wrong there. But what's also good is though I said we use a lot of data and analytics, and what's cool about that is I'm able to see what I'm looking at and how I'm making decisions based off the data, and then going and selling against that, and then seeing the impact that's being made afterwards. So I can see the direct correlation of what I did, what I put together, what I looked at, and actually seeing it come to fruition in real life in stores, on the marketplace, and seeing how I'm helping grow the business. So that's what I enjoy about it. A money thing too from the PC is not, is good too. So it's always helpful. Let's be real.
I would say, I think the thing that I find most rewarding is being able to find the signal within the noise. We commonly find in products at scale we'll have hundreds of millions of data units, and it's just a giant block of noise that's entirely meaningless until you hit that just the right vein, and all of a sudden the signal makes itself apparent. And it's just it's very rewarding to be able to see that. And then I tell my dog, and every time he's very, very excited. It's fantastic. It's absolutely fantastic.
So Signal and the Noise is actually a book reference. Nate Silver, correct? Great book about modeling and forecasting, written for folks that don't necessarily have to have a PhD in machine learning to understand it. So folks like me can understand it quite well. A great book on modeling and talks about a lot of the failures that forecasters run into. There's not a lot of success stories in that book, but still a great book to read nonetheless. With that, I'd kind of like to open it up to the audience. If you've got questions, throw. Oh yeah, sure.
Look, you know how you watch TV, and every time they show a programmer in TV, they type 10,000 words a minute, and they write this beautiful, artful code that works the first time as soon as they hit it, and it's faster than they expected. I don't know any of those programmers. I don't know any of them. It is a sloppy, messy business. And the reality of the failure of any model or anything that you put together is that it is simply the next step to success. The way to be successful in the tech field is iteration of your own work. So if it fails, if it doesn't run, if you get errors, don't be dismayed, don't be disheartened, be like, oh, it's crap, I put all this work into it, it's not gonna work. This is how it works. Just debug it and move to the next phase. That's how it works. I just wanted to add that.
No, that's a very true
Very
statement.
true.
And great addition. Any questions? Not everybody at once. Oh, okay, sure. Let's go over here. So just so everybody here, the question is, how often do you utilize Excel in the workplace?
I use Excel most of the day, and my entire team really does. We do all of our material requirements planning in Excel and our forecasting in Excel. We've pretty much maxed out what those sheets can do. I know Randall mentioned space earlier, and that is one of the major limitations. I do love Excel for our business because we're able to really see what's underneath the hood, I guess you could say. It's easy to track formulas and understand why things are what they are, which I think is a great way to learn about supply chain. If you were using planning software, for instance, I think that would be something that would be more challenging. You'd have to get really curious and really talk to the IT team a lot to understand what's happening with that software. So we use Excel heavily, and I think a lot of businesses do. Very big companies I know of that are using Excel to forecast as well. So if that's something you're thinking about going into, I would recommend Excel for sure.
Henry, you want to add maybe comments?
Yeah, no, absolutely. I mean, we're a billion-dollar company, and we are absolutely using Excel. It's easy. Right now, it's an easy language that everybody can understand across the organization, and sometimes we're exporting data from other outside resources. Putting it into Excel is the easiest way people know how to use it, manipulate the data. I know, again, we'd love to build some crazy databases, but sometimes we're just trying to get the information quickly, turn it around, and have something that people are familiar with and comfortable with. So Excel is a huge aspect of our job and our organization.
Henry hits on a really interesting point there. Having been involved with some massive transformation projects where companies go out and spend millions of dollars to go buy a new software system, a new tool, a new planning system, and months, if not years, of implementing it, and then all the planners, all the sales teams, everybody still goes into it, pulls data out, and does everything in Excel. Still a very, very common, lots of nods, very, very common problem. Or that's just kind of the world that we live in. Most people know Excel. That's what they're comfortable with. So that's a big chunk of where people spend their time. But any other questions? Yeah. So just so everybody heard, how does artificial intelligence impact operations, and what can we do to prepare for that?
Well, hopefully it takes that human piece of decision making out. And so the more that we use data and we make decisions off data that sits on the back end, the more we model exactly what an AI would do. And so if you think about the way that, and we'll call pretty much anything artificial intelligence these days, or we love, machine learning was the one before artificial intelligence, but the reality is it's a loop. And in that loop is the collection of information, decisions made from the information, the evaluation of that decision feeds right back into the collection again, and it starts again. And so I think we're going to see more and more of that as time goes on. What we do to prepare for it, and what we do, and you hear this apocalyptic sense of we're all going to be out of jobs and there's not going to be any work. We are a long way from that kind of AI. Like the Terminator movies are great, but that stuff is not around the corner by any means. All of this works much better as a combination of human and machine input. So to the extent that we allow machines to digest large volumes of data and provide us information that help us make decisions, I think that we have a good symbiotic relationship between the two. So I don't see the future as bleak or dystopian in any way. I just think that in in reality, all of our skills will need to be a little more technical as time goes on.
Yeah. What are the benefits of using Python, R versus object-oriented programming like
Oh.
Java?
Yeah, I can take this one. Let's see. So I know the intro computer science classes are taught in Java, so it is a bit of a pain to have to learn Java in computer science classes, and then for you to come here and me to tell you actually don't learn that, do R and Python. I see you nodding, so I think I have guessed the situation here. So the reason you want Python is built for scripting, and so a lot of the programming that you do in data is scripting. And so you might get a programmer purist who says, okay, that's not real programming because it's not object-oriented program, functional programming, whatever you want to throw at it. It's scripting, but that's fine. You're still solving problems. You can laugh all the way to the bank. And it really doesn't matter. So Python, another reason you want to learn it, not just that it's for scripting, is that a lot of the open source tools for analytics, whether they're on the engineering side like Airflow, or they're on the analysis side like PyTorch or Pandas, or what's the other library? Scikit-learn is very popular. Those are written in Python. They're Python all the way down, and so that's why I would recommend, that's why I give you the extra work of learning Python instead of Java.
There's an interesting graph that's produced every year by GitHub. And what they do is they take all of their libraries and they plot out from the years before what those libraries are actually written in. And now, when you turn a library on or when you turn a project on, you start a repo in GitHub, you don't select what the language is. They have a little bot that runs through there and looks and says, oh, this is a Java library, this is a Swift, this is Python, this is whatever it is. Look at what those are. It's very interesting to see JavaScript has been on a steady rise since the Node server product was introduced. And so it depends. When it comes down to really languages, it comes down to what do you want to do? If you want to do hardcore back-end speed stuff, Java. Why? Because it compiles to C, right? So it's super fast. If you want the flexibility, you want to use a Leatherman, not a scalpel, you're going to use Python. If you want to do front end, you're going to write JavaScript. If you hate yourself, you're going to write R. So R is a great language. It is a great language. It is statistically very granular, so you have control down to a very, very low level of computation. Fantastic. However, if you're sending spaceships into Mars, great, you need R. If you're working in the regular world, you probably do not need to use R. The learning curve for R is steep. It's very, very steep. It's been around for a while. So yeah, I agree. I think Python is on the top of that list for sure.
So I'm going to disagree on a slight point. So there is base R, which I definitely agree is has a steep learning curve. You got like $signs and points everywhere. It's a pain in the butt to learn. But the tidyverse, I would argue, bridges that gap for a lot of beginners. If you learn R tidyverse, so it's going to be a universe of like tidy libraries, you can do a lot of the really awesome stuff very quickly. You can transform data, maybe do like a group by, and then do a plot in like a few dozen lines of code. But that's in the tidyverse. And so if you're going to learn, if you really, really want to learn R, I recommend going the tidyverse way, not the base R, which is just regular R, which I agree is a huge pain in the butt to learn.
Very back. Almost very back.
Or bad for your industry, or is that correct?
Good. Very, very, very good. All of statistics right now suffers from the curse of dimensionality. So what happens is I look at something and I want to have as many possible components to that data as I can possibly get. And the more components that I have to the data, the more attributes, the more variables that I add in to a model, the more accurate I can be. The problem is, I am always faced with a dimensionality reduction problem so that it can be done in a computational time that isn't going to take 7 years of calculation. So if we can move to something that calculates better than what we have now, we will be in much better shape. Computers today are not functionally different for like the last 10 years. The reality is they're just more of what we've already had. The chips are smaller and they're stacked more and we have more RAM and more cores, but we have not had a functional shift in the way that computing is done. And so I am very hopeful that, I don't know if it's going to be quantum computing, but I'm hopeful that we can get that next block. Because we're computational.
Can you explain dimensionality a little bit better and kind of explain why that's challenging?
So for take a trying to dream up an example here. Take a clustering example. So I want to put things into groups, and to put something into groups, I have a list of attributes that adjoin any given thing. The first startup I worked at was an online gaming startup, and so if you played a game online, I wanted to recommend another game like it online. So I had these attributes that were associated with the game. And so for those attributes, I could say, all the first-person shooter games that had, first-person shooter with the bows and arrows or whatever else it was, right? So you have this list of stuff. The problem on that list is that I have to cut the list off, maybe at the top 5, maybe at the top 10, when really I would like that list to be like 200 items long, because they all have lots of granularity to them. And the more the items that are, the more the characteristics that are available, the more accurate the clustering becomes. But I can't do that because I don't have the computational background to be able to make that happen. That's dimensionality. So you have to reduce the number of data components in order to get your code to run within time.
Oh, yeah, sure. So how do we use historical data to predict the stock market?
My guess, as an ensemble method, don't try to predict individual stocks, try to predict indexes. Look how well the S&P index has done, and look at the trend over time. If you bought the S&P index 10 years ago, you'd be doing fantastic today. The ups and the downs, the overall don't matter. That's why mutual funds are so important, and that's why when you look at retirement plans, oftentimes retirement plans are almost never vested individually in stock. They're almost always invested into mutual funds that are, what's the word that I'm looking for? Not diversity.
Portfolio?
ETFs.
Yeah, your asset allocation is essentially diversified. That's the word, among a number of different things.
Eggs in multiple baskets.
Yep.
Exactly.
Yep, indexes are the same way. So my answer would be index funds. Sure.
Wait till you get into economics and learn about the efficient market hypothesis, and it's impossible to meet the market, or so they say. Sure. We'll do 2.
Data engineer. Are there any specific certifications that you recommend me looking?
Yeah, I would not recommend any certifications out there. I would recommend really Airflow. I would get that installed on your computer. Build something really simple. All you need is, remember, we're just fancy copy and pasters, so just copy and paste a file from one place to another in Airflow. And then, that's you're set. You're 80% of the way there. I'm giving out the secrets. So Airflow, number 1. So Python and SQL, I hope you've heard. I would go deeper into SQL, the data modeling stuff. Really learn data modeling and database normalization, things like that. So that you can speak about these eloquently, and then employers can be like, oh man, this guy seems like he knows what he's doing. Let's hire him and pay him money, right? And and you can sell these skills, the database stuff, so database theory, data modeling, Airflow, and Spark is really popular. It's not super needed here in the Treasure Valley because Spark is really for like the Netflixes. that have tons of data, and we're really just getting Spark is the other thing, but I wouldn't recommend it too much if you're looking to stay here in the Treasure Valley. Really, Airflow, Python, and yeah, welcome, hopefully.
All right, last question before we need to wrap up. Yeah.
3 to 5 years of experience for data analytics.
Well, actually, let's kind of go down that's a great question to end on, I think. We'll just kind of go down the line.
Build something. Build something. Build anything. Build a weather model. Build a stock model. Anything, but build something. The barrier to entry to you building a product and having a web or a mobile presence with that product is absolutely none today. It'll take you longer to dream up what domain name you want than it'll take you to get something up and running online. But build something. And then, when you go to an interview, take over. So they start asking questions, you're like, oh, that's exactly like something I did. Let me show you how this works. And take over and take charge of it. That way, you keep the narrative on the thing that you've built and you highlight the skills that you've put together. People that interview you will draw corollaries from that information and you will be a much better candidate.
It's tough on the phone.
I got a perfect follow-up for that. So I graduated fall 2017, and summer 15, I got rejected for like a finance analyst position at Wells Fargo, and it was an internship. And I got rejected, and one of the reasons I noticed was I wasn't good enough at Excel. They asked me, how good are you at Excel? And I was like many other ITM 105 passees, was like, pretty good. And so I took it upon myself that summer of 15 to learn Excel well, and Excel, Python, whatever, the language, it doesn't matter. The project, the learning is what matters. And so what I did was, I was delivering pizzas at the time. I started collecting about 10 columns for each delivery, delivery time, order time, tip amount, order amount, things like that. And so it started off as an Excel project. I had 1,300 rows, just a couple of months of delivery data, and every interview, it'd be like, they'd ask me a question and I'd force the conversation, just like you said. Actually, this reminds me of a time when I collected 1,300 rows of pizza delivery data. And so if you can build that narrative in interviews, I know it is very hard to find internships sometimes. Sometimes life gets ahead of you, and the summer's gone, and it's like, shoot, well, now I have to focus on classes. I can't be searching for internships right now. And then you graduate, and then it's not fair that the employers ask for that much, especially for junior positions. But if you can build this project, I'm still milking that pizza delivery data. Just to give you examples, I did Python stuff, I did statistics, linear regression stuff on it. That was like the next level up, so I could get me the next jobs, the more advanced jobs that pay more, by the way. Just to bring that up again. And it's not about me, it's about the career, and it's about you doing that. And so after that, I gave a talk on it, because most of the results were null. Most of the results were invalid, or didn't tell you anything. It was just noise. People tipped what they were going to tip. And so I gave a talk on that at Pi Data in New York in 2018, last year. And so these kind of projects, you can continue to gain value from them in different ways. You really just take something on for yourself and show that curiosity and drive, and hopefully an employer is willing to catch you on the other side, because they do exist. It happened with my current job. I wasn't technically qualified, but they recognized that I am passionate about learning, and so they gave me that chance, and I'm sure if you keep trying, you can find that chance too.
Go ahead.
Look how far Angel's come now. So, sorry, with pizza delivery. So, but I would say the same thing. Like, obviously, be curious about things. Sometimes, to be honest, getting different experiences, taking a job you may think. Honestly, when I graduated college, I was like, I thought I was going to be the CEO, right? And I didn't get a CEO job. So I'm like, why not? I got a degree. So sometimes taking those experiences and leveraging that. Honestly, I started as one of my first or second jobs was going store by store, putting product on the shelf. But as I was doing that, I started tracking the data analytics and what I was doing, how to sell better. And that gave me the experience to become an analyst. So kind of I progressed from there. So just taking different experiences, getting your foot in the door sometimes, and then showing them how you're passionate and what you can do and learn. And then get a mentor too. Find somebody else who has, that experience, or find a mentor that can help teach you some of that stuff. Big networking too. Go to networking events, things like this, talk to people using your network, and that's how sometimes I can get your foot in the door.
Okay, last comment of the night. What do you got?
Oh, no, that's too much pressure. That's way too much pressure. I did want to share that there are some industry specific if you're in supply chain. We have an Idaho chapter. It is APICS, formerly known as APICS. It's now ASCM, the Association for Supply Chain Management. There are certifications you can do through that I do find very useful. And it's definitely a leg up. I see CPIM, CSCP preferred on a lot of applications right now. So that might be a good strategy too. If there are some certifications, I know you mentioned there probably aren't any you can think of for the data side. But that is a good one for supply chain. So wanted to mention that. And then we have a really good, I think, community of volunteerism as well. So you might find projects that you can volunteer on. That can get you motivated to work on these projects. So sometimes having that self-motivation to build something, it can be helped if you're working with people together on projects in teams. I think that's also a really important thing when you're looking at work experience. I think people are looking to see how well you can work in teams. So going the volunteer route might work as well.
Well, everyone, I hope it was as educational as it was for me as it was for you. I think I said that backwards. It doesn't matter. Hope you learned a lot. Hope it was a good night. And yeah, let's give our panelists a round of applause.